Hello po. Another thing that you need to remaster before going to the triangle similarity concerns, aside from the review on short review on relation and proportion, is a short review on the two-column proof and proving of triangle congruence. Why do we need to come up? Why do we need to remaster these concepts? Is connected in understanding the different theorems and different presentations of triangle similarity later on. So let's start with two-column proof. A two-column proof is one of the formal ways to prove a statement. To the two-column is composed of the statement column and the reason column. In this case, we are going to plan out all of our reasoning by placing organized statements and corresponding reasons that supports each statement before arriving to the item that we are trying to prove. So let's talk about the situation here. You would like to prove the statement that the acute angles of a right triangle are complementary. We all know that a triangle has three different interior angles. And we all know, based on our understanding before, that the sum of the interior angles of the triangle is equal to 180 degrees. So if we are already given that it's a right triangle, and we are assured that the other two triangle angles rather are acute, it is stated that those two acute angles are complementary to each other. Complementary, meaning they sum up to 90 degrees. So we need to arrange our understanding as to complementary 90 degrees, 180 sum of the interior angles of a triangle, 90-degree angle to come up with our reasoning. Now, the proof may come in different forms. This statement may be proven in more than six statements or less than six statements. I'm just going to cover six statements here for presentation of the proof. I already have given first row and the last row. The first row is always placing the given. Okay? If we are going to construct something else, we could also use that as a part of our proving construction. We could actually apply it after we have placed the given. Because in any situation, we should always start with the given. And that's already bonus. Here, we are given the situation that triangle ABC is right angled at B. So place that as your first statement and simply state the reason. It's the given. Okay, and we need to from here we need to reach the statement that angle A and C are complementary. This is a connection that there are three interior angles here, A, B, and C, and angle B is already right angle. So the acute angles A and C should be complementary, the item that we are trying to prove here. So to complete this proof, the next statement here must be connected to the given. Okay, our given is triangle ABC is right angled at B. And since we are talking about angles, based on the given, let's look at the given angle, which is angle B. So if angle B is right angle, its measurement, okay, its measurement is equal to 90 degrees. Okay, the reason behind that is given as it's a right angle. So we can just simply state that its reason is based on the definition of a right angle. Okay? By stating this is support that we could assume that angle B is 90 degrees, and this is in connection to the previous given. Okay, when we try to come up with a proof, make sure that the next statements are connected to the previous statements, not necessarily to the next one. It may jump to another row if there are more rows before, as long as it's connected to the previous row. Okay. Now, since we have this situation right now, what is the best thing that to be added here? Again, please be guided that our goal is to reach angle A and angle C to be complementary. Okay. So how do we come up with those relationships? Since we have not expressed here angles A and C, only angle B first, to reach that situation, we need to come up a statement here presenting angle A and angle B. And what could it be? Okay? We could say here that the measurements angle A, measurement of angle B, and the measurement of angle C, that's C, that's C, sums up to 180 degrees. That is actually based on a theorem. This is on the triangle angle sum theorem. Okay? It's the name of the theorem which supports that the sum of the interior angles of a triangle are congruent. Are the sum of the interior angles of a triangle is 180 degrees. And we have proven that already in our module, so no need to prove it here. Why do we come up with this situation here? Our goal again is to come up with the relationship of angle A and angle C. But since angle A and angle C are not yet presented in the first two rows, we need to come up with a situation wherein we can present angle A and angle C. Now you might say angle A and angle C are acute based on the given, but it will not lead to a relationship between the previous statement of angle B here. We come up with this because we can use now the substitution property, and rather instead of using angle B here, we could actually say the measurement of angle A plus substitute here 90 degrees plus the measurement of angle C sums up to 180 degrees. This is a connection between rows 3 and 2. And by concept, we actually applied here the substitution property of equality. So simply substituted the value for angle B. And look at what happened now. We have dissolved angle B and we are left already with angles A and C, closer to our goal that would like to prove for. And what is the next step here? Is actually we could remove 90 or subtract 90 both sides, right? And then we come up with a situation, measurement of angle A, remove 90, subtract 90, so that would be removed. We are left with measurement of angle C is equal to, as we also subtract 90 degrees here, we should also subtract 90 degrees here. So 180 minus 90 will be 90 degrees. Again, we use the subtraction property. Property of equality. Okay? And look at what happened now. From row number 5 to row number 6, since the measurement of angle A and angle C is the sum of them is 90 degrees, we can now say that they are complementary in base of what? The definition of complementary angles stating that if the sum of the measurements of two angles 90 degrees, they are complementary. So proving coming up with two-column proof is not necessarily easy, but what you could do is to connect reasons, statements from one to the other. Do not go to other situations. Some of you might say, since it's right angle at angle B, you might say hypotenuse. You might come up with the term hypotenuse, but we don't need that because our goal here is to prove complementary angles, and hypotenuse is a side. Okay, you may also use the Pythagorean theorem if you want, but then again, Pythagorean theorem concerns on the sides, not the angles. So you just simply need to follow the relationship between angles until you reach the intended relationship here. Again, the proof for this may come in more than 6 steps, may come in less than 6 steps, but I have presented here 6 steps where with which I believe could present it better for your understanding. So as soon as you will be asked later on to provide a two-column proof, first give the given. Next, look at the given and which of the items in the given could probably lead you into your item that you wanted to be proven. Here, we are given with triangle ABC is right angled at angle B. We come up with a right triangle. You can look for, again, use hypotenuse. You can use a Pythagorean theorem, blah, 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 and other relationships in a right triangle. But when you're looking at the item to be proven, which is on complementary angles, so you only look at the relationship between the angles. Okay? So please try and practice. Look for other theorems. Try to prove them on your own to master the two-column proof. Again, the purpose of coming up with this is for us to be prepared in triangle similarity where theorems also needs to be proven. Without this, you may have you may find hard time or troubles in understanding the similarity between triangles. So the next few videos will still be connected on coming up with a two-column proof. Please stay tuned for that. Goodbye.